Hi everybody. In today's lesson we're going to be talking about the exponent rules. There are 7 of them that we're going to be studying, and then we'll apply some problems with them. So let's go ahead and get started. Alright, the first property that we're going to be talking about is the product of powers. This is when you have the same base and they're being multiplied and they have exponents, and in this case what we do is we add their exponents. So just terminology wise, in this case the x is called the base and that little 3 right there is called the exponent. I might also say the power, just so you know. It means the same thing. So in that case, what we are going to do is, since the bases are both x's, and we just go ahead and take their powers, which is 3 plus 2, and we add them on the side here, and then we say that the answer is x to the 5th. Alright, the example does not change just because the bases are now a number, which in this case are 3. The exponents are still going to be added together, so we're going to do 2 plus 4 equals 6, and the answer is going to be 3 to the 6th power. The way I see that is I have 2 3's here and 4 3's, so I have a total of 6 3's. Alright, when we have the quotient of powers and they have the same bases again, what we do is we subtract their exponents and we go from the top minus the bottom. So we're going to do 3 minus 2, 3 minus 2, which equals 1, and therefore our answer is x to the 1, or you could just write x because we know that everything has a power of 1. Alright, same rule applies here. When the base is a number like 2, we are going to take the exponents 4, which is the top exponent, minus the bottom exponent, and in this case we get negative 2. So the answer is going to be 2 to the negative 2, but what we'll find out in the next rule is that that is not okay. So the final answer is going to be 1 over 2 to the 2nd, and I'll explain why that is in just a minute. Less than a minute. Here we go. Let's explain that rule. Now, one of the rules is there are no negative exponents allowed in the exponent rules. Someone said that, so we follow that rule. So when there is a negative exponent, and by the way, this is over 1, what we do is we move the base and its exponent from wherever it's at. So if it's in the numerator to the denominator. So right now it's in the numerator. I'm going to move it to the denominator, and when I do, the negative 4 becomes positive 4. And then obviously I can't have nothing up there, so I'm going to put a 1, so then it doesn't look like it's something divided by x to the 4th. It's got to have a number, so we do a placeholder. Alright, in this case what you'll see is y to the negative 3rd is in the denominator. Since the exponent is negative 3, we are going to take this whole thing, these are attached together, and we're going to move it up, and it's going to become y to the 3rd. Now it is over 1, but it's unnecessary to write it, so y to the 3rd would be our final answer. But notice once again the exponent went from negative to positive 3. Same thing here with 4 to the negative 2 power. It's over 1. We do want to take this whole thing and we want to move it down, and when we do, it becomes 4 to the 2nd power, and the 1 is going to be on top so it doesn't look empty. And in cases like this where I know what 4 squared is, I know 4 squared is 16, I'll write 1 over 16th as my final answer. Now this is my favorite one because anything to a 0 power is equal to 1. So x to the 0 power equals 1, 16 to the 0 power equals 1. There's a past about this problem. I remember that test that my teacher made with a lot of things inside, crazy stuff, and then it was to the 0 power. The answer was 1. I was working it out. It took me a while. Alright, so let's look at power of a power. It's when there's a power and then there are parentheses with a power on the outside. In that case, what we do is we multiply the powers. So it's going to be x to the 8th power, because what we do is we do 4 times 2 is 8. And then we do the same thing when the base is a number like 3. We still multiply the exponents 2 times 3 and we get 3 to the 6th power. So I'll show my work here. 2 times 3 equals 6. Alright, now the other 2 powers or exponent rules are about the same as the one that I just showed you. They're just more things inside the parentheses. So for example, here there are 2 bases, 1, 2, 3 bases. but all of them have an exponent on the outside. So when it comes to a power product, what you're going to do is multiply the power that's outside to every single power. And sometimes they don't write the power. For example, in this one, it's x squared and y. We know it's to the 1 power. It's so much nicer when you write that. That way you don't forget about the y. If you don't, I know I personally tend to forget about the y. So what we're going to do is distribute the 3 times 2 and also 1 times 3. And we end up getting x to the 6th and y to the 3rd. And that's our final answer. Now, for the second one, it's the same concept. 2 has a power of 1, x has a power of 1. So we are going to go ahead and distribute that 3 to both of the ones. And we get 2 to the 3rd and x to the 3rd. Now, I do know that 2 to the 3rd is 2 times 2 times 2, which is 8. So I'm going to write 8x to the 3rd as my final answer. All right. So the next rule is the power of a quotient. Remember that quotient just means division. So these problems are very similar to the ones on top, but instead of multiplication, there are divisions involved. So in that case, we still have all of our exponents. We have a 3, we have a 1 on the y, a 4 on the z, and we have a 2 exponent on the outside. So we're going to go ahead and multiply each single exponent with the 2, and everything that's on top will stay on top. In this case, we have x to the 6th power, and everything in the bottom will stay in the bottom. Y to the 2nd and z to the 8th. And that's our final answer. Same thing here. 2 has a power of 1. X to the 3rd has a power of 3. We're going to go ahead and multiply that 3 on the outside to the 1 as well as the 3. So we get 2 to the 3rd and x to the 9th. And we know that 2 to the 3rd is really 8 over x to the 9th. That's our simplified. All right. Now, on all these problems I've been saying, and we're done, but I haven't really explained when you know you're done. So you know you're done when all of your exponents are positive and each variable occurs once. So for example, a base 2 is only seen once, a base x is only seen once. And when you see that, you know you're in good shape. So let's practice that idea. In the next 3 problems, it says, are these expressions simplified? Yes or no? If no, why? So if I look at this expression, I could tell that it is not simplified. So the answer is no. And the reason for that is because of m to the negative 2. There is a negative exponent. And according to the rules, all the exponents are supposed to be positive. So that's the reason why. Now, let's look at B. I have a base A, a base B, and a base C. So none of the bases are being repeated, and all the exponents are positive, 3, 8, and 7. So therefore, we know that this expression is simplified. And on the last one, the answer is no. I hope you see it right away. And the reason is because the variable r appears more than once. Or you could say appears twice. So we know we would have to simplify that a little bit more. All right, now we have 9 problems ahead of us, and then once we get those 9 done, we are ready for the homework. So let's start. All right, when I look at example 1, the first thing I notice is that y to the 0 power is 1. So I know this is going to be multiplied to 1. And then I also notice that there are 2 x's, and I know I can add their exponents. So I'm going to do negative 2 plus negative 5, which gives me negative 7. So that's x to the negative 7. But I also recognize that I'm not supposed to have a negative exponent. So I know this is over 1, so I'm going to move that down. And I get 1 over x to the 7th times 1. But really that times 1 doesn't do anything, so it's 1 over x to the 7th would be our final answer. Now you might have thought about things differently. That's okay. Our final answer should still be the same, regardless of how you start your problem. In example 2, you have 7 to the negative 3rd power. So I'm not really happy about the negative 3, which is an exponent being negative. So I'm going to go ahead and put this over 1 and move it down. And I get 1 over 7 to the 3rd power. Now 7 to the third power is 7 times 7 times 7, which if I type that into my calculator, I get 1 over 3/43. Alright, look at example 3. We have m to the third divided by m to the negative 2. So first, I would like to move this up, just because I don't like working with negative exponents sometimes. M to the third, and that comes next to it, so m squared. And there's nothing underneath. I could put over 1, but I don't need to. But I'll do it just so that you can see it. And then we end up having two bases with m. We're going to go ahead and add their exponents. So 3 plus 2 is 5, and m to the 5th is our final answer. All right, let's look at 4, 5, and 6. So in 4, 5, and 6, well, in 4, we have two exponents inside the parentheses, negative 2 and 3. We have 1 on the outside, so we are going to go ahead and multiply these out. So we get x to the negative 4 and y to the 6th. And since x to the negative 4 is negative, we are going to move that down, but the y to the 6th will stay because that's positive. It doesn't have to move. And x to the 4th will drop down. So only the negative exponents move, not everything. And that would be our final answer. In number 5, the exponent on the base 4 is a 1, as well as the 1 on the 5. And we're going to go ahead and distribute the power of 2 to both of those exponents at once. And we get 4 squared divided by 5 squared. 4 squared is 16, and 5 squared is 25. So it's 15 divided by 25. All right. And number 6, we're going to go ahead and distribute 4 times negative 2, and we get a to the negative 8. But once again, since it's negative, we are going to take it from the top to the bottom. We end up getting 1 over a to the 8th power. Okay, remember, we're not supposed to have negative exponents. All right, number 7 is very similar. We have a 3 to the 1 power and x to the 2nd power. We're going to go ahead and distribute that power of 3. We get 3 to the 3rd power and x to the 6th power. 3 to the 3rd power is 27, x to the 6th power. Number 8 is my favorite because everything inside of this is to the 0 power, which is equal to 1. That was easy. Looks complicated, but it's so much easier. For number 9, which is our last one, we have a exponent here, and we have parentheses in here. So this 2 has to multiply to the parentheses. So we have two exponents being multiplied. So we have s to the negative 3rd power times s to the 4th power. And we can go ahead and add their exponents since they are being multiplied. Negative 3 plus 4 equals 1. And that's s to the 1 power, or I know some of you just like to say s. And those are all the examples I Thank you so much for coming and listening to our lesson. See you in class. Bye.